Hello, the Darkness344 here, and I just want to say thanks for the 300 subs. We have hit 300 subs, and I know it's been a bit of a while since my last video, as 1 month ago. I am still active, do not worry. I've been responding to comments and stuff. It's just that I've been got an SSD now, so yeah, I had to transfer all my files, and I also was working on several things, and I couldn't really be bothered. That as well. So I've almost finished the programmable prom computer, the actual Scratch side of things. I've almost finished that, actually. Do I have it right here? This is, let's see if I can find it, which is taking a long time. Where is it? I have it here somewhere. I think it's this one, yes. No, it's not that one. It's this one. I've nearly finished it. It's almost done. There's only one feature that I haven't got on it so far, which is basically just I think it's like some sort of editing bit. So you'll be able to choose which computer you want. So you can choose to load up certain computers. I'll add more. I'll add support to all my new ones when I make them, and it's basically just a simple compiler. You can even create your own custom computer with custom lengths for your bits, custom commands and everything. It's pretty cool. When it's done, it'll be very cool. I was having a look at making an emulator, but probably will not do that. Let's load up Minecraft. But what was I going to do today? Yes, I was going to be showing you two different types of RAM that I've come up with. One which I'm using on this new epic computer over here, which is the new computer that I am working on. It's going to be pretty cool if I can actually finish it, because I don't want this to turn into one of those 5.0 projects, if you know what I mean, where I kind of just gave up on it. But this computer will basically be 8-bit computer. Well, technically a 7-bit computer, maybe with 8-bit support, because I'm going to be doing, it's going to have a sign bit as the 8th bit, which is going to be yeah, so I guess I might be able to toggle it between subtraction and addition. So it'll be able to either be 7-bit subtraction, kind of doing subtraction data, or 8-bit normal data. But that means I might need to modify the flags a bit where it does the jump if overflow. I don't know about that one. But yeah, it's going pretty well so far. I haven't been doing much on it. At the moment I've got 64 lines of code. It's going to be, yeah, 64 lines of code. I think, no, it's not expandable. 64 lines of code. Conditional, a lot of conditional flags, which are going to be shift. Oh no, these are not conditional flags. These are ALU functions. These are conditional flags. If the ALU equals ROM, which will be like a hard-coded value, which you'll be able to code in your user interface like this, and you'll be able to flick the levers. This will be like linked up to the user panel. If the ALU overflows, of course. If ALU is negative. If A equals B, if A is greater than B, or if A is less than B, which are actually quite useful operations. And I have successfully implemented that in this small, well, large space. And the ALU that I'm using is a very cool, compact design by Nubosaurus. And yeah, it's basically his ALU, and I've made some minor modifications, like replacing the yucky looking slabs. I know I'm a glass block guy, not a slab guy, with lovely glass blocks. And I also modified it a slight bit, because over here, I think, no, it wasn't here, it was over here, he was using like I think it was an XOR gate to toggle between inverting and not inverting. It was over here. But I just used this instead, which is much more efficient, which is just a multiplexer, which the second input is just inverted. So, which I can show you down here real quick. This is a basic multiplexer where you have your values like this. Let's just build one up like this. So this is your basic multiplexer. You have two inputs, one here, one here. If you input this one, it'll come up with that. I've forgotten my control lever. Let me just go up like this. Oops, I just broke that piston. And then if we go like this, that is incorrect. I built it too low. There we go. So this is our control. This is input 2 and this is input 1. So if our control is 0, input 2 will output 0 if it's on or off. However, input 1 will output 0 if it's off and 1 if it's on. However, if we turn our control onto 1, input 2 now does the thing, as you can see, where input 1 gives no output. So that's basically what this multiplexer is, and you can slap an inverter onto it like this, get rid of input 2 and combine the inputs just into input 1 like this. You'd have your input 1 would be like this, and then you can also bring it up to go into here like this, and then so you can input to both of them like that, right? And then you just invert this one by like like this. That's here like this, and then you just invert this one like this, and that's basically what this circuit is. However, we just put it down there to make all of this a lot more compact, and as you can see, it inverts like that, and you can decide whether it's inverted or not. So if it's not inverted, 0, 0, 1, 1, but when it is inverted, 0, 1, and 1, 0. Pretty cool. We better actually do the RAM soon. Yes, I'll get onto that in a bit. Don't worry, guys. I'll probably at the start of this video I'll have like a skip to certain time zone if you want to build the RAM. Speaking of which, we should do that now. So this is going to be a cache for the computer, and we have the input of data and the output of data here, which I've currently got as on because I was doing a bit of testing. So we're just going to turn all these levers off, which I've done a terrible job at. So basically, this is a very simple cache design. It's using a D flip-flop with a nice little, let's just put a piece of redstone with a nice read design like this, which is extremely laggy. Wow, that's very laggy. Yeah. Don't use pistons, guys, or you get that. But yeah, this is a very simple read design. And yeah, it basically just goes and put data in, you save it, and then you can choose to read it, and it'll just read that data. At the moment, as you can see, I've saved 1s to it, and it's very laggy because there's a lot of pistons, which I should really have thought about that. But, and then the second design is all the way over here, which is one that I've just come up with and I'm very proud of, and is not that one, that's the first one, it's this one, which is the second design. It uses slime blocks, sadly, I know, and whatever the heck glazed terracotta is. You could use obsidian instead, but this just looks nicer. And as you can see, I've already broken it. What fun. Let's just get one of them. And this is the second design. And yeah, I forgot about that, you need to put these here. Don't think you... What have I done wrong now? Oh yeah, because this has to actually go down here like this. There we go, it fixed. So this is the second design. You have very, very, very small cells. However, the difference between the first design, as you can see, these are only 2 wide. So you can, your outputs are, there's only 1 block in between them. However, this second design uses repeater latching, which is, you can latch repeaters like this. And there's 2 blocks in between them, making this the total design 3 blocks wide, tileable. And the best part about this design is it's absolutely tiny, as 1, 2, 3, 4 wide. Only 4 wide. That is pretty small. I know Java's only like 2 by 2 RAM, but this is absolutely tiny for Minecraft RAM in Bedrock Edition. And you can tile them just like that. So 4, 1, 2, 3, 4, 1, 2, 3, 4, just like that. There does not have to be any gap in between them, unlike my previous designs. This was my smallest previous design, where it uses a comparator as the read line. Let's show you this. So if you wanted to read from it, you could go like this. Let's actually write some data to it. That would help. There we go. And now if we read from it, it uses the comparator. It's like you can toggle the comparator to read or not, like that. And when the comparator reads, it just sends it to the piston, and the piston goes down and puts the redstone on this line. That was my previous design. It's 5 blocks wide, because you have to count air blocks as well, and that's horribly inefficient when you have a design that's 4 blocks wide. So let's actually build these. So for those who've skipped the video, first of all we're going to start, skipped to this part in the video. First of all, we're going to start by building this 2 wide design like this, which is a new design that I came up with, pretty compact. And then after that we'll be building this even smaller design over here, which has a gap of 2 between it, so it's 3 wide, which is only 4 blocks long, may I add, which is very, 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 very compact for Bedrock Edition anyway. So first of all, let's go build this one. So first of all, you're going to have to start by making our actual data inline. So basically the data inline. And the way that I'm going to be building these is I'm going to build 2 cells this way as well as 2 cells this way on both of them, so you know how to stack it both this way as well as this way, because that's always useful. It's kind of annoying when people only build like 1 cell and you don't know how to stack it this way or this way. So you're going to build your data line like this, and I'm just going to build 2 to give myself a head start. We're just going to have redstone on top of this. These are nice flat data lines, so no like dips and curves like some of my old designs might have had. And wherever you want to start your cell, we're just going to place a piston. So I'm going to start my cell here, and a redstone block like that. Now we're going to go place a block here, 2 blocks there actually, and a block here, and we're going to break those and place a piece of redstone on this one over here. So now when we activate this, the redstone block turns this piece of redstone on. Now we're going to place another block with a piece of redstone, a block like that, and then break that one, and so you have this odd T shape. Then we're going to have a redstone torch. You need this, so remember to place that, that's very important. Redstone repeater, and some redstone like that, with the repeater on 1 tick. Then, since we're going to be stacking it this way, we're going to have a redstone torch, and as you can see, normally with a D flip-flop, you'd actually have a block down like this, and a redstone torch like that, and that would be your normal D flip-flop. However, we're going to modify this design by instead placing a block here and a piston here, sticky piston, breaking that block, placing a piece of redstone on that, put a block here and a redstone torch under that, and it should go like that. And then the easiest way to fix that is just by going like that and going like that, and then just breaking them again. And then, as you can see, it stopped. So then we're going to place just a regular block down like this, and we're going to go down one, across one like that, and we're going to break that like that. Actually, we're going to keep that there, because then we can place another piston, a sticky piston down like that with a redstone block. Then we can break that one. Now we're doing the actual reading part of the circuit, where before we were doing the actual cell that saves it and the writing part of the circuit. So first of all, we're going to go over here, place a block like this and like that, and this will be our write line, and we'll have our read line down like this, and this will be our read line. So as you can see, write line, read line, and this piece of redstone will go into this block like that, and we'll have a block like that. No, that's not how I've done it. I've done it one up to save a bit of space. We'll have a piston like this on that block, piece of redstone like that, and then when we activate this line, it'll the redstone will pass through that block, making this piston go down. And then we can just place our reading line like this. And so when we want to read from this cell, we just flick this one and it'll read from that cell, or whatever data's in it. And the data that's in it at the moment is just a 1. And if we want to set that to a 0, we can just go like that. And when we read, it just displays a 0. But I'm going to keep 1 in it for now. So when we read from it, it gives a 1. Now we just want to do this line down like this. And we're going to just stretch this line out all the way like this. Now, the second cell is quite easy. We're going to build one over here first, then we'll stack them out this way because that's probably just better. So let's just break these levers, and we're going to go 2 out again, and like this, and then we'll just repeat the same thing up here. So we're going to piston, sticky piston even, redstone block, and then go over like this with our redstone. And then we can stretch this across with the redstone torch. Block up like that. Redstone torch. And a weird T shape. Redstone torch. Repeater. Redstone. And over here we're going to have a block. Then the piston. Then a piece of redstone on top of that. Block. Redstone torch. And a normal block like this. And I'm going to stop this real quick by... That didn't work. Oh yeah, I'm just going to stop this by doing this. Now, we got to put the other redstone block in like that. And there we go, and you should have just stretched this line like this. And now we can read from both the cells like this. I think this one's a 0 and this one's a 1. And we can write to the cells by, let's extend this line, by doing this, like that. That writes to the cells. And as you can see, we've written 0s to them because there's 0 on our right line. And when we read from the cells, they read 0. So now if we write 1s on our right line, if we go 0 and 1 and write it, when we read from it, it gives us 0 and 1. Perfect. Now let's actually build the rest of this line over here, this read line. So just like that. Then you have your input, you have your output, and yeah, they are kind of skewed, which is a bit annoying, but you can always, to unscrew them, you can just go like this with the redstone torches, and it inverts them, but it unskews them, as you can see. It realigns them, and then to fix that you can always just go like that again and invert them again. That's how I fix that unscrewing issue. Now let's build the second set of cells over here. So we're going to place a piston over down like this, 1 block away from this, so you have a 1 block gap. I've tried doing it like this, but sadly it's still not possible. I have to think of a different design to do it that way. And we're going to place a redstone block and go down, of course, just like this. Break that. Whoops, I broke this one. That is not good. Just like this. Up. Block like that. 2 blocks like that. Repeater. Redstone dust. Like this. The redstone torch there. Torch. And then we're going to place a block, then a piston. Break that block. Just like that. Piece of redstone. Torch, just like that, and then it flickers like that, but then we can just fix that by activating the right line as well as activating the... You don't need to activate this, but I just find it's easier. And then as you can see, it stops flickering. And this was actually meant to be a block, not a redstone block. So I made sure, yeah, I did put a block there. And then we have a sticky piston, redstone block, and then this will be our read line for this cell, and I'm actually going to stretch them both out like this. So there we go. Now we have our read lines for these cells and our write lines for these cells as well. Now I need to build a cell here, of course, so that is just easy as doing the exact same thing as this one, where we just go like this. So now we want to place a block up like that. With the torches, repeater, redstone. Block here, because if you place a piston here, it gets extended down, so it's kind of annoying. Block, piston like that. Block, piston, redstone. Block here, redstone here, and so when we activate that, both of them go down if this one's up like that. And we'll place a piece of redstone here with a torch on the inside like that. And this, of course it flickers, so we're just going to activate it like that. So now we can read from that cell. Now, so let's input some data. So the first number we're going to input is just 0, 0, and we're going to save that to both cells. So save it to cell 1 and save it to cell 2. Now when we read from it, so read from cell 1, 0, 0. Now read from cell 2, 0, 0. Perfect. Now let's save the number 1, 1 to cell 1. And let's, while we're at it, just cell 2 as well. So read from cell 1, 1, 1. Read from cell 2, 0, 0. Perfect, so that works. Now let's just do 1, 0 on cell 2. Like that. That was the wrong line, that was read. That's right. And 0, 1 on cell 1. So we're going to write that. Now you can leave these on while you're doing it, while you're reading, but let's read 0, 1 and 1, 0. So this is the first RAM design. So if you do use this and you show it off, maybe please do leave some credit. So let's go with the second RAM design now. So this one's a bit simpler. Well, actually not really simpler. This one's a bit more complicated, but and it's 3 wide instead of 2 wide. So you're going to have 2 blocks between your inputs, which may be a bit annoying, but is a lot more compact and I think just as fast as that one, if I'm not mistaken. But you'd only build this one more for the compactness and not the speed, because if you wanted to go speed, you could build a lot. There's bigger designs that are much faster. It's just you go compactness because it's just more efficient for your computer. And this design is 1 block gap, and this design is a 2 block gap, and you use them depending on what your need is in your computer. So for this one, we're going to go up like this and break these blocks, and this will be your writing lines again, but this time we'll go 2 blocks in between them, and let's just go a bit like this. Make it long. So to start off, this one's actually different because you do need a slime block and immovable block. So we're actually going to replace the fireworks, that's annoying, with some of that, which I've been using glazed terracotta. You can also use obsidian, which also works fine. So now we're going to place a piston just like this design, facing down, sticky piston, of course, not a piston, which I broke. And actually let's start on this side because it's easier. Then we're going to place a slime block and a redstone block down like that. Then we can place a block down like this, 2 blocks down like that, and a repeater like this. So this is going to be the actual mechanism we're building right now, where we place a block to that, to the side of that, and we place another repeater like this. So first of all, I'm actually going to show you how repeater locking works, if you don't know already. So you have a repeater here and a repeater here facing into that repeater, and when you activate this repeater, it locks this repeater, so as we can see, nothing can pass through it. So even if I stretch out this line, it's on and nothing will pass through it. However, if we unlock this repeater, you can pass stuff through it, and if we leave it unlocked while there's an input and then we lock it, it retains that state whether this line is on or off, as you can see. And so we can make simple RAM cells out of this, just like these ones we're doing right now. So that's what we're going to be building here. So if we go like this, place a block on that repeater, you can always block up if you can't do that, and we'll place a block this side too, blocks on top of them like that, and then just redstone like that. And with this block, however, we're actually going to have to put a piece of light blue glazed terracotta or terracotta or remove block, because when this goes down, the slime block may try to move this block, and that is not good as it will destroy the circuit. So now we've got this, then we're going to be building the second part, which is the actual reading part of it. And the way we're going to do that is by placing a block on that, so the redstone can go into this block. Torch down like that, and under that torch, actually no, over here to a block to the side of that, so you go block, block, we're going to piece of redstone dust. Now there's two ways you can do this. You can either have it so the reading line is directly under your writing line, which is the way that I'm going to do it. The other way is you can have it skewed to the left or right if you're on this side. However, that's kind of a bit annoying and there's not really much point why you do that. So the way we can do it is either go like this or go like this. But we're going to go like this, as that's easier. So like I've done over here, which I did these to the left, I need to rebuild those lines later. But as you can see, we have our redstone like that, redstone torch, and we're going to go down like that. And you can either, of course, have your line over here as well. Instead, you can have it either way, because the torches both line up. But we're going to do it on this one, because that lines up with our writing line. And then we're just going to bring this out like this, just stretch it far like this. And as you can see, we can read from this by, yeah, we have to put a block over here first. So now we're going to do the actual reading mechanism where we tell it to read. So the way we do this is we're going to place a block like this. Did I do it this way? No, I did it like this. And a piece of a redstone torch like that. Now if we go like this, up like this, a piece of redstone on top of that torch with blocks up like this, and redstone on top of these, whenever we activate this redstone line, it will deactivate this torch over here. And yes, I know this is interfering, but the way we fix this is by placing blocks like this. You don't need to place a block here on top of this one when joining the cells, you just need to place them like that. And the way we fully link this up is by going like that. And that is pretty much one cell complete. Now, let's just break this because we don't need it. Now this is a bit confusing, but now we're actually going to stack them so it makes more sense. So the way we're going to stack them is by repeating what we did over here. So by going like this with the piston, and then over here we're going to have the repeater like this, and another repeater facing into that with that block on that repeater, and redstone on top of that. Then we're going to have the terracotta over here. I keep almost calling it ceramic, but it's terracotta. Then the redstone line over that. So as you can see, when we activate this, it goes all the way over that. Now there's the slight issue of when this signal runs out, but I think you can just put a repeater here because, yeah, you can just put a repeater there like that to reach that side. But we're just going to put redstone like that. So when you stack it, if this signal runs out, you can just put a repeater like that. And the same with this over here, you can just put a repeater on that. And the same with this design over here, if your signal runs out, put a repeater in between this like that. It shouldn't affect too much things, and the same with that. Now, so we've done the actual cell part. Now we're going to need to build the mechanism that controls the reading of the cell, which is straightforward as a block over here, redstone torch, a block in front of that redstone torch like this, and a piece of redstone on top of that. And as you can see, you can put the torch either here or here. Of course, we're going to put it here, and our reading line just like this one over here. And as you can see, now we just have to build this line, which is as easy as stretching this out. And of course you put the blocks over here so it doesn't interfere. You can really put a block here. It might make building a bit easier, but I don't really recommend it as there's not much point. And then, now we need to build this torch so we can go up like that. Redstone torch like this, and a piece of redstone dust like that. So there is our both cells stacked this way across. Now we're going to stack it this way too. So, whoops, I just broke that. But first of all, let's give it a test. So we have our input here, our output here, our write down here, and our read over here. So at the moment, I think there's 0 in the cells. So if we read, we get 0 out of both cells. Now if we write something, let's write 0, 1. If we write that to the cells, actually no, this has to be inverted, I forgot. So when you're building it, let's just stretch this out like this. This line has to be inverted like that, or else it will not work properly. And I think this one may have to be as well. No, it does not. This one does not have to be inverted. So we're going to write 0, 1 to this cell, and the way we do that is just by flicking that lever like that, or giving a short pulse. And now when we read out from both our cells, as we can see, 0, 1. Pretty simple. Now I'm just going to write 0 to it again, like that, as you can see. So now let's stack it this way. So the way we do that is by doing the same over here, but over here we can just go directly like this, because the cells are literally like this. And as you can see, I don't think that will provide too many issues. Let's see how I did it here. What have I done different here? I think I did a mechanism a bit different in the writing here, where instead of... Oh yeah, I didn't use redstone torches, I used pistons. So forget what I said about these redstone torches over here, we can just break them, and instead we're going to use pistons like this, so they don't interfere with the next cell. And the way we do that is by basically, so we have, let's break this. So we have our cell here, and in line with this one, we're going to place a piston, another piston, break this piston, you could have used a block there, and a piece of redstone down like that. So now when this line is activated, as you can see, the redstone will power this. And this is because if we placed a redstone torch down like it was earlier, it would go through this sticky piston, this slime block, and it would activate that, and that is not what we want whatsoever. So now let's do the same over here, like that. And now when we activate this line, it goes down like that. Pretty simple. And that is why we actually have to invert this. So we do have to invert this line as well, which isn't too much of a hassle. Now we can build this cell again like this way. So we're going to place a block like this, no air gaps as you can see, so it's very compact. Slime block, redstone block, and going down like this, cross one with our redstone repeater, and another repeater facing into that repeater, that's a lever, and our blocks like this, with the piece of terracotta like that. And now we got to do the rest of this design, so we're going to have a block with a torch out like that, I think, with a block down like that, redstone dust, and a thing like that. The other way I've seen you can do it actually, is by placing a redstone torch here on the inside, but either way does it just fine. Now we're going to build the same setup over here. So over here we're going to go up like this and across like that, inverting it like that. And this is directly above this block, by the way. So your repeater's here, and you have a block, and then you have this bit over here. And as you can see, we can stretch it out like this, and these bits of course line up, so you can just block off like that. And then on this one we have the piston going down like that with the redstone block like that, so we can activate it and it turns on and off the redstone block. Now we'll build the exact same thing over here on this cell as well. So stick piston, slime block, redstone block going down like this, even lower actually, with our repeater here, repeater there, terracotta on top of that one, block here, and then we're just going to go out like this with redstone on top of them, blocks here to block this redstone off, block here on in front of that repeater like that. Redstone torch here or there. Block over here, block down like that. I think I did it. Oh no, I did it on the inside over there on that time. We'll do it on the inside over here as well, actually. It really doesn't matter, either way works. Piece of redstone and your... I did the redstone torches on the inside there. They're actually meant to be here instead. So they line up with these. Now, we need to do this piston as well, so that's just easy as going like this. And there we go. Now let's actually test these cells. So I'm going to write the number 00 to both cells, and the way I do that is just by writing it to both cells like that. And now when we read from cell 1, 00. When we read from cell 2, 00. Now I'm going to write the number 11 to both cells, so 11. When we write it to cell 1, write it to cell 2. Read from cell 1, and we have 11. Read from cell 2, 11. So always check your cells just in case you've made like a little mistake, because that always happens. Now we'll write the number 10 to cell 1, and the number 01 to cell 2, like that. So, as we can see, did I even write it properly? Let's go again like this, and then we write it like that. I'm pretty sure it's all connected up properly. As you can see, always test your cells, because there's always maybe a little mistake like that. Let's just write it again. Now when we read from this one, we have 10, and when we... that was writing to it. And when we read from this one, we get nothing, because I didn't write anything to it. So let's write this to it. Write to it like that. Oh, I was clicking write instead of read. When we read from it, we get 01 basically. So I got confused between which lever was which. But yeah, there we go. That's two simple, very, very compact RAM designs for Minecraft Bedrock. Hope you enjoyed. Please like and subscribe, and I am out. See you later.